In this video, we're going to continue with examples of volumes of solids of rotation. Okay? This time we're going to look at the volume of a solid of rotation when the region bounded by y equals x and y equals x squared is rotated around the line y equals 3. When we just looked at this function this region y equals x and y equals x squared, we know it goes from 0 to 1, as we can see here. And we know the shape of that, so we're going to redraw that, but this time we're going to rotate it around a difference. So here's our region. It goes, there's that banana shaped region that goes there from here from 0 to 1. This is at 1. Now we're going to rotate around the line y equals 3. So first, we always have to make a choice. Are we using the disk method or are we using the washer method? The disk method would be if it has a solid, if there's going to be no holes in this shape. The washer method would be if when we rotate it, we have a hole in the middle. So we look for a gap between the line of rotation and the region itself, and we certainly have one here. So this is going to be a washer method problem. So we're going to have an inner radius which goes from here to here. There's our little r, and then our capital R is going to be the outer radius. Okay, and so R, we'll start with capital R. We have to figure out this distance from this line y equals 3 down to the function, that's of course x squared. So that distance is 3 minus x squared. And then little r here, the inner radius, little r is going to be 3 minus x. Those are the distances between. So now our volume would then be the integral from 0 to 1, don't forget the pi. And then it would be the outer radius squared, so 3 minus x squared squared, minus the inner radius squared, 3 minus x squared dx. And we can throw that in our calculator. So math 9, the integral from 0 to 1, and we'll multiply by pi when we're done here, of 3 minus x quantity squared, 3 minus x squared squared, I have to add another one, x squared quantity squared minus 3 minus x quantity squared dx, and we're going to multiply that times pi because we forgot to put it in front of the integral. So that would give us a volume of 2.72, and I forgot the third decimal here, 722, or 2.723 would be acceptable as well. Okay. So that's when we're rotating around a different line here. Alright, find the volume of the solid of rotation when the region bounded by y equals 0 and y equals x cubed and x equals 3 is rotated about the line x equals negative 2. I do believe that should be x equals 0 as well. We'll graph for this here. Y equals x cubed. There's our y equals x cubed. This should indeed be x equals 0 instead of x equals 3. Y equals 0. Okay. No, actually that's incorrect. It is correct at x equals 3 because x equals 3 is right out here. And so it goes right here, and then this is the region we are rotating. So again, we're rotating around the line x equals negative 2, so we're rotating around this line. It's a vertical line this time, and you can see there is a gap. So again, we're going to have an inner radius Here's our inner radius in the red there. And our outer radius would go all the way to 3 there. Would be our outer radius. So capital R. Well, that's from -2 to 3. It's 3 minus -2, which is 5. So the outer radius is just 5. And the inner radius is from the function, but we have to have it in terms of, this is an x, but we can't just use x. Okay, we have to solve this equation for x. So x would equal the cube root of y. Because we're rotating around a vertical axis, we need to solve for x here. So this would be this distance, this red distance, that is little r. This is the square root of x minus -2, the cube root of x, I'm sorry, cube root of y minus -2, which is just the cube root of y plus 2, that extra distance. So now we can write our integral. It's pi times the integral from 0, because now we have to go on the x-axis. We start here and it goes up to where this line is going to meet with this x equals 3 line. Well, since x is 3, y is going to be 3 cubed, which is 27. So it goes from 0 to 27. Y equals 0 to y equals 27 of the outer radius squared, so 5 squared, minus the cube root of y plus 2 squared, okay, dy. It's of course a dy problem, not a dx problem this time, and that you can put into your calculator to get yourself the answer, but that is what the integral would look like.